Hi everyone, my name is Miss Nguyen if you haven't met me yet, and today we're going to go over how you're going to calculate percent yields of a reaction. So we have to calculate a percent yield because in real life, when we're actually doing a reaction, not all of the reactant will react to make 100% of the product. And so in order to calculate how much we actually made versus how much we were supposed to make, we have this formula. So there's the actual yield, how much we actually made, over how much we were supposed to make, the theoretical yield. We multiply that by 100 and we get the percent yield. So this is our first example problem. It's pretty simple. It says that you should get 4.86 grams of product, and we actually got 4.53 grams of product. And it tells us we need to calculate the percent yield. So I'm gonna, that's how much I should get. That's how much I actually get. And I'm trying to find that percent yield. And so we plug in our numbers. 4.53 grams is how much we actually got. 4.86 grams is how much we were supposed to get. We multiply by that by 100, and we get a 93.2% yield. Don't forget to box your answer. Okay, so I'm going to erase all of this. The next example we're going to go over is a little more involved. It's going to use some of our knowledge with limiting reactants. So we have methanol, and it's produced from a reaction between carbon monoxide and hydrogen gas. Suppose that 68.5 grams of carbon monoxide is reacted with 8.60 grams of hydrogen gas, and that produces 35.7 grams of methanol. We're supposed to calculate the percent yield. So our strategy with this is we are given how much we actually made. That's how much we actually made. But we don't know how much we were supposed to make. So using our numbers, we're going to calculate how much we were supposed to make. We're going to compare that to how much we actually made, and then we're going to find our percent yield. So first thing we have to do is write a chemical equation. So if you think you're ready to, you can pause the video, see if you can write an equation. Unbalanced, start with that. Check if this is what you have. If you didn't pause for the chemical reaction to write this, pause it right now and try to balance this equation. I think we should all be able to do that. So pause the video, balance the equation. Okay, so if you balanced your equation correctly, this is what you should have. This is the equation that we're going to use to do our calculations. Okay, this is our equation. Okay, so we have two reactants, but how do we know which one is the limiting reactant? Well, if we calculate how much product each reactant made, given how much we have of each, whichever one has the lower product made, then that will be our limiting reactant. So we have to use both of these numbers, both of the things that we were given. So we're going to start with grams of carbon monoxide, and we're going to calculate how many grams of product were produced from that. And so we have grams of carbon monoxide, so that means at the bottom of our conversion factor, when you have grams of carbon monoxide, on the top we're going to have moles of carbon monoxide, so this is going to be the molar mass of carbon monoxide, right there, with this, so we can cancel out those units. Because we have moles of carbon monoxide up here, we have to put moles of carbon monoxide at the bottom of this conversion factor. The next one on the top, we're going to have moles of methanol because that is our product and that's what we want to find. So that will be our next conversion factor. We got these numbers from our equation. We can cancel out those units Then lastly, we're going to put moles of methanol, the bottom of the last conversion factor, and we're going to put the grams of methanol at the top to get the unit of our product. So that's the molar mass of methanol. We can cancel out our units, and we can multiply across to get 78.4 grams of methanol produced. Next, we have to find the amount of product was produced for 8.60 grams of hydrogen gas. If you think that you can do it, you should pause the video right now and work through this calculation, because we just did it the same thing up here. Down here is just with hydrogen gas. I'm going to walk us through it anyway, so pause the video, try to do all of this. Okay, let's see if you did your calculation correctly. So we have 8.60 grams of hydrogen gas. That means that at the bottom of our conversion factor, we should have grams of hydrogen gas. At the top, we should have moles of hydrogen gas. So this will be the molar mass of hydrogen. It's right there. We can cancel out our units. And then now for our second conversion factor, we're going to have moles of H2 at the bottom. That means we have to have moles of our product on top, so moles of methanol. That's going to be our conversion factor. These numbers come from our equation. We're going to cancel out units, and then we're going to write our last conversion factor. So moles of methanol should go at the bottom of this conversion factor. Grams of methanol should go on top. This is going to be the molar mass. That's the numbers we should get. We can cancel out those units, and then we can calculate the grams of methanol. We should get 68.4 grams of methanol. And so what we have to do now, that was just our limiting reactant, we have to figure out which one of these was our limiting reactant. So whichever one produced less product, that's going to be our limiting reactant. So between 78.4 grams and 68.4 grams, this one is less, meaning that our hydrogen gas is our limiting reactant. And so we're going to use this number as our theoretical yield, how much we were supposed to make. Remember that 35.7 grams is how much we actually make. So we're going to use this as our theoretical, this is our actual, and we're going to calculate our percent yield. Okay. Choose that final answer that is lower. Choose that one. Okay, so that's our equation again. Our last step is just to calculate the percent yield. So this is our equation. See if you can pause the video, plug in the numbers, see what percent yield you get. So 35.7 grams was how much we actually made. This was given to us in the problem. 68.4 grams is how much we were supposed to make. This is based on our limiting reactant. We divided these two, multiplied by 100, and we got a 52.5% yield. That's how much product we actually made. Don't forget to box your answer. I think that's it.